Okay, so again, the second exam's a week from Wednesday, and right, so let's go through the homework assignment. And hopefully everybody got it, or some part of it. What I want to do is to go through my solution and sort of my thought pattern about how I attacked the problem. Nick thought it was an interesting problem. I guess it was harder than other stuff that you guys have done. And let me start out by saying, again, I'm trying to motivate here. There's a lot to absorb in this class. I'm trying to motivate here this idea of using functions, and that the use of functions is not a problem. Let me restate that. Using functions is a tool for you to make it easier for you to solve problems. I understand that there's some learning and some hurdles to overcome in terms of the mechanics of it, and it seems like it's more bother than it's worth. But as these problems get harder, you really can't solve them. The only way you really solve them is by breaking them up into chunks that are solved by functions. And so that's sort of a preface to what I'm going to talk about today. So hopefully for people who didn't get it, or struggled with it, even if you got it, I still think looking at the way another person does it, hopefully, I think mine is a good solution, will give you insight into ways of attacking it in the future, so that perhaps not only did you get the solution, but perhaps you can arrive at it more quickly. So I always start off saying I'm going to call a main function, and the main function is going to be this sort of outline or overall plan of things that I want to do. So it's sort of a matter of taste of how much functionality I put in main and how much I offload into sub-functions. There's no one correct answer. So here's my thought pattern. So I'm starting this thing, and okay, so I understand the problem. Obviously, the first thing you need to do is to have a very good understanding of what you're trying to solve and have some understanding of the details. So for the first part of the problem is that I've got to now give the person the rules of the game and get from them how many games they want to play. So my first thought was, fine, I'm putting out the rules and getting how many games. Why don't I create a function that does that? Of course, I can call it whatever I want. And that function I'll call intro will print out the rules and also prompt them for the number of games. It will, if asked for, yes, it'll validate that the number that they put in will be correct, and it'll return that value to me. So my first thought is, I don't want to attend to the details of what printing out the instructions are and doing the validation. I'll do that later. All I want to do is sort of this top level, how I'm attacking this, and I know that I have to have a function that does that, and that function will prompt the person for the number of games, return that number of games, it'll be validated, and I'm going to store that into my variable called numGames. Great. Now I know the number of games that they're going to play. So now let's go and now play the game. Well, I'm actually going to do this two ways. So to play the game, now I know that I want to play this a number of times, but maybe what I first want to do is, why don't I just play one game and see if I can get this to work for one game. And so I'm going to say, okay, the game is played by first getting the person's guess. So I have to ask the person for the guess. I have to validate it. I'm going to hand this out, so you don't have to type this in. You're going to download it, actually. So just follow along. So I'm going to say, I'm going to get the person's guess. How am I going to get that? I'm going to get that by asking them for their guess. So I'm going to call this function called getGuess, which is going to prompt them for their guess, and I'm going to store it in the variable guess. Okay? The next thing I need to do is, now they've made a guess, now I've got to flip the coin and see what that coin toss was. So I'm going to now have a variable that's going to flip the coin, and I'm going to now, how am I going to get that coin toss? I'm going to now create a function called getFlip. So getGuess gets the user's guess, getFlips simulates tossing the coin. I'm going to take whatever that is, and both note that intro, getGuess, and flip are going to return values, and I'm going to store that in the coin flip function, in the coin flip variable. And now that I've done that, now I can see who won, so I'm going to now check to see if the guess is equal to the coin flip. And if it is, well, then they won the game, and so I'm going to say print and that's sort of the rudiments of playing one game. I realize I have to play a number of games, but in attacking this, I might say, why don't I solve a simpler problem first before I worry about adding in the harder part about playing a number of games. Clearly, if I can play one game, it seems to me I can then extend this to play multiple games. So this isn't the final solution, but it's my progression through getting the solution to this. What you should buy into is this idea that as I talk this through, is that I'm not writing the details to these functions from the get-go. I'm simply just saying, this is what I think I want to do. Offloading to later to actually implement each one of these particular functions. I'd be lying to you if I said that every time I do it, I get the right detail and I have the right breakdown. That'd be a complete lie. You shouldn't believe me. No one ever does that. What would happen would be that I figured, that's wrong, I've got to put this functionality in this thing, but it's a good way to start. And again, writing these programs, everybody, it's always better to get something working and change that. It is to me, this is the analogy. I have difficulty writing essays, I hate term papers, so I'm teaching instead of actually being a student. I have to write research papers, that's a little easier. But I'm sure everybody's had the experience of the following. Would you rather do the following? Would you rather generate a paper having nothing written, or would you rather have somebody give you a whole bunch of text, and what you've got to do is change that text and have it sound better, and perhaps add a few things? And the experience of most people is it's much easier to edit and change than to generate something. So if you get something running, it's much easier to take that stuff that's running and then try to enhance it, and try to get everything running from the get-go. So two things from this. A, I sort of have my first pass breakdown of what these things, the functions that should be. And B, I've now simplified the problem to not doing a whole bunch of games, but to just playing one game. So now that I've done that, I say to myself, I want to see if I can get this thing to run. Okay? And so I'm going to lop off each one of these functions one at a time. So I'll write the intro function, and the intro function says print welcome to the coin toss game. And I'm going to prompt them for the number of games, so I'm going to create this variable called numGames. It happens to be the same variable that I use in the main, but that's just a coincidence. And now I'm going to validate numGames to make sure that it's greater than 1. So they're not getting out of there unless numGames is greater than 0. I'm going to return numGames. So what I might do at this point, okay, not required, but what I might do at this point, I'll get rid of the blank space here, I'll put stuff back in, is maybe I want to just see if my intro program works. So a technique here to sort of test each individual function is, I've written my main routine, but I just want to test the intro function. What I can do is if I highlight all these, watch this guys, if I highlight all these rows, and what my intent is I just want to execute the intro function. I haven't written the other ones. If I try to run this program, it's going to bomb because get, guess, and get, flip don't exist. But I want to run this anyway. And so if I highlight these rows and go up to Format, and then click on the buttons called Comment Out Region, what it does is it inserts the hash mark, 2 hash marks, you only need 1, in front of all those lines of code. And what that means is that they become comment lines, not code that gets executed. And in this way, now I can run the program. So if I were to go now and say run, great, how many games do I want to play? I want to play 3. That seemed to work. And I could have, if I wanted to, just to make sure, I could have put a print statement in here, but that seemed to work. So now I've tested my intro program, right? And if I want to now put this stuff back, I can just highlight those rows, go to Format, and click on Uncomment Region, and that'll take the hash marks out. So it's very, very easy to comment and uncomment a whole section of code. And again, I just went to Format, and I went to Comment Out and Uncomment a region. So my next function that seems to work well is to define get, guess, and so I prompted for it, and now I'm going to validate that it's okay. And you could validate it in a couple of ways. You could have done while guess. Well, the way I like doing it is guess not in range 0, 2. So if you remember, the range command generates number range. And so if I say range 0, 2, that effectively generates the number 0 to 1. So I'm testing to see if guess is not in that range, meaning it's not a 0 or 1. Okay, so that's one way to test it. You could have tested it. That's the best way. To me, that's the best way to do it. You could have tested to see if guess is less than 0 or if guess is greater than 1. So alternatively, I could have said guess less than 0 or guess greater than 1, that 2 would have been invalid. It's the same test. I just sort of, to me, this sounds good. I mean, it just.
We can also say like guess not in list 0, 1.
Yeah, very good. Guess not in. Very good. That's probably even better than the range because I think it's clearer. Changing my solution. Get points for that. Imran. And now if it's not, then I'm going to print And now that I've gotten a valid guess, I'm going to return guess. I could test that, but it seems like this is going to work. So now I've knocked off guess and I've knocked off intro. Now I want to do get flip. And so in get flip, what I want to do is I want to generate a random number. And if you recall, if you want to generate a random number, one of the things you need to do is you need to import the random library, the random module. So you have to have import random. And now that I've done that, I can say flip equals random dot rand int 0, 1. So that's going to generate a number between an integer between 0 and 1. And I want to tell the user what they got. So if flip is equal to 0, and now I just want to return what the flip is. So I'm going to say return flip. Okay, so I got intro, I got get flip, get guess. So I think I've got everything to play one game. So let's see how that works. So I'm going to tell I'm playing 3 games, but I know it's only going to play 1 game. So I'm going to guess a 0 for heads. The flip is tails. I had an incorrect guess. So it looked like it played that 1 game correctly. I could play it again. Let's just make sure. Well, there's not much to change. I'll run it again, but in any case. I'll put some invalid number in for number of games. But what if I put in -4? Well, now I've tested the validation that if I put in a bad number, it's not going to let me do that. So I'll put in 3 games again. And now I'm going to enter my guess. Let me test to make sure my validation works. I'm going to put in a 2 for my guess. And it says invalid input. Your guess has to be 0 or 1. Okay, great. So I'm going to put in now, I'll put in a 1. And the flip is tails, and my guess correct. So that seemed to work. Okay, so before I move on, I just want to reinforce this idea that I've done 2 things. I've actually taken the problem, and I've made it a little simpler because I haven't addressed playing multiple games. I said, let me just get it working for 1 game. So I've simplified the problem by having it just work for 1 game. I also haven't printed here at the end, if I play multiple games, I have to say how many games I won and what my winning percentage was. But again, when I attack these problems that are harder, I say, let me solve a simpler problem. Let me take sort of the essence of a simpler problem and get that working. And now that I've got that working, I've convinced myself that I've got that working, then I can go on to put in those other bells and whistles. And then secondly, I've taken the problem and I've broken it down into different functions and not worried about how I'm going to implement those functions at the beginning. I'm just going to now break them into parts. And then once I've broken that into parts and I've convinced myself that this seems to be a good framework, I then go back and implement each one of those individual parts. To me, it's undeniable that doing it this way simplifies things into smaller chunks of things that need to be done. and to me makes a lot of sense in terms of how to attack a problem. I get it, in the beginning, you're just trying to get something to work, but I really think that this discipline really does help in solving harder problems. Okay, so now that I've got this thing working for one game, now I've got to get it to work for any number of games. The number of games is indicated by the variable num games. So if I have a set of code working, if this set of code works for one game, how can I get this code to repeat so that it's going to work for the number stored in num games? Well, whenever I want to repeat the same code, I'm going to use some loop structure, whether that's going to be a while loop or it's going to be a for loop. It's going to be one of those. In this particular case, I think I want to use a for loop because the for loop allows me to do something a certain number of times. That's what the for loop is great at. So you want to do something 4 times or 8 times or 20 times or however many times indicated by a variable, the for loop is the way to go. So what I want to do is I want to execute this set of code, which is the playing of the game, asking for the get, flipping the coin, and determining the outcome. I'm going to want to do that over and over again, and so I think I want to use a for loop. So before I have the get here, I'm going to want to say for, and I can have any variable here. I is traditionally the variable you use, for I in the range of how many games I want to play. So the way I can specify how many games I want to play is by 0 to num games. I could have had 1 to num games plus 1, but I prefer not doing that. So this is going to then repeat a number of statements num game time. But what statements do I want to repeat? Well, I want to repeat all of the statements that played one game, but of course those have to be indented from the for statement. So let me highlight them all and let me indent them. So to play the number of games is indicated by what the user wants. I think all I have to do is just execute those lines over and over again. And so I just inserted the for statement. And now let me run that and see if this works now. So I want to play 3 games. Okay, my first guess, I'm going to guess heads. Oops, it was tails. I'm going to guess heads again. It's tails. This is not a fair game. I'm going to guess heads again. Well, believe me, it's a random number generator, and you have a probability of generating 3 tails in a row. Let me make sure my code isn't screwed up. I don't think it is. Get flip. Right, the rand int is inclusive between 0 and 1. I just got unlucky. Okay. So that seemed to work. So now I've run this thing for however many games the person wants to play, and now I think the only thing left is to tally up so I can print out the number of times I've won and also what my winning percentage is. So in this structure that I've played, okay, so what I need to know is how many times have I won the game? Well, I know I've won the game is when the guess is equal to the coin flip. It's a guess correct. So at that point, what I could do is, I know I won that particular game. I want to keep a running total of how many games I won. So I could create a variable called numWins and just increment that by 1. And of course, since the numWins variable appears on the right-hand side of an assignment statement, I've got to initialize that to a value, which of course is going to be 0. So now I have a variable that's going to track for me the number of times I've won. And now I get to the point of now what I want to do is I want to print out a summary. So the summary is going to have the number of coin flips, okay, the number of times I've won the game, and then the percentage of winning. So after this for loop has completed, I now know the number of games that I've played. That's simply num games. I know the number of wins. That's num wins. And I can compute the winning percentage. It's simply num wins divided by num games. So I have a choice here. I could now put in my main code the print statements that did that. But I probably would say, you know what? I might want to do other stuff later on. This partitioning of these tasks here seems right. So what I want to do is instead have a function that is going to print out this summary. So I decide to create a summary function, okay, and the summary function is going to print out the number of games I've won and the number of wins. This is now different than the other functions that I've written in that the other functions that I've written don't take any input. You know, intro simply prompts the user and gets the value, and get guess prompts the user and then prints the value or returns a value. And get flip generates the number doing the random number generator and returns it. But summary is going to be a function that is going to get the numbers, the number of wins and the number of games, and it's going to print out that summary. So I have to pass it values. So what values will I pass? Well, I'll pass it the number of games, num games, and I'll pass it the number of wins, num wins. And the summary isn't going to return any value. It's just simply going to take these two numbers, the number of games and the number of wins, and it's going to print out this summary, and it's not going to return any value. So you'll notice that there's no assignment statement, there's no left-hand side of the summary as opposed to what I had here for intro and get guess and get flip, because it's not returning a value. All it's doing is it's taking these two numbers and printing out a summary. So it's not going to return anything in the way I've partitioned this. So now what I want to do is write the summary function, and it's going to take two parameters, the number of games, and just to show you it doesn't make any difference, and the number of wins. So I've just created two different variables, but of course everybody should be comfortable with the fact that the names of these variables in the function definition can be different. The correlation between these variables here and the definition of the function and these variables here when they're called is that num games, when this is called again, games gets initialized to the value stored in num games, and win gets initialized to the value stored in num wins, and that's it. Then there's no other linkage. And now that I have this, I can print out So I have a print statement that prints out the number of games or number of coin flips. The coin was flipped, and then games is going to be whatever the variable games is, which is whatever it's going to be num games times. And then what I want to print out is so how many times you guessed correctly? Well, that's stored in the variable wins. Good. I guess I wanted to promise it. And then finally, I want to print out the winning percentage. And I want to divide the number of wins by the number of games, and I want to round that, and I want that to be a percentage, so I'll multiply times 100, and I want to round that to 2 decimal places. And I'll put a % sign at the back of it. Oh, there was a heads. I won. Yay. Tails, I lost. Boo. Well, I'm getting better. So here, now at the bottom, I have the summary. The coin was flipped 3 times. You guessed correctly 1 time, and my percentage is 33%. Now, the way I did this partitioning, okay, again, obviously I could have gotten rid of all of these functions and just incorporated all this stuff into one main function. But I think it helped me to do this in terms of breaking down the problem so I got it right earlier. And B, if I were to add stuff to this, which we'll see in a minute, it makes it much easier to add code to this routine, to this program, to do more things. If it's broken down into these functions, and the idea of the functions is it does a very small part of the problem, and you write it after you've written the main routine. Were there different segmentations of this problem so that you wrote different functions? So, I mean, I'm assuming the homework you did, you didn't break it down this way. You might have broken it down into different functions. Could I, for example, forego having the summary and simply take these lines of code, these 3 lines of code, and have it here instead of summary? The answer is, of course, I could have. Would that have been a reasonable way to attack the problem? I guess. I'm always looking, I guess when I write programs, is that I'm always looking to say, well, if this program is going to be used in the future and if this program is going to be enhanced by somebody else, how can I write it so that it's going to be more easy changeable? And the creating of the functions does that because the functions do one small part. And if I have to add another small part, all I need to do is call it another function and somehow insert it into the main routine or one of the subordinate routines. So that's really the idea behind functions. Are there any questions, any comments, any different, better ways you guys did it? Okay. So I'll do that later. So why don't we do the following now? Why don't see if this is available. So go to Blackboard and go to the content section of Blackboard and go to lecture 18. And download in lecture 18. It should be available. Is it lecture 18 available? So here is under HW16-1-01 version solution. Why don't you download that? That's the program. It's the way I did it last night. It might have some slight differences from what I typed in, but it's materially the same. Download that and open it up into the Python editor. Okay, so here's the code that I just wrote. I want you now that you understood what I did is to enhance this program as follows. Forget about this. Prompt the user for how much they want to bet before each game. So now when they play the game, okay, in addition to guessing whether it's heads or tails, prior to guessing whether it's heads or tails, I want you to ask them, how much do you want to bet on this game? And if they win the bet. So if they bet $10, they win an additional $10. And if they lose $10. So I want you to prompt them for a bet on how much they're going to bet on each game. And then at the end, where we have the summary, in addition to the summary that we have, we're going to also print how much they won or lost. So the interaction is going to be, again, you come in, you're welcome to the Toy Coins game, you can enter in the number of games, but now the first thing you're going to do when they play the game is you're going to say, enter your bet. And why don't you validate that the bet is greater than 0 and less than 500. Okay? And then, and then you're going to play the game as normal. Nothing different is happening here. The only difference is at the end of the game, you're going to now print out two numbers. The amount of money they lost, so when they placed a bet, no, the amount of money they won, so when they placed a bet and they won, the total amount of money they won, and then how much they lost, that would be the amount they bet in games that they lost. Okay? So,
what's the restrictions on the bet amount?
yeah. Okay? Yep.
After each, do you want them to see if they want money on it, or do you just want to see a summary?
Just the summary.
Okay.
Okay. So how should we start? Surya?
The way I did it was I made a new function called getMet. I added it first to the name because I knew where I wanted to get it, and then I went back and actually.
Okay, so was this everybody's, that's the way I would have attacked it also, right? Seeing a lot of head shakes, Nimra, Katie. Chris shaked his head but the wrong way. Okay, we'll get back to him later. Fix his neck. So, so it seemed to me, and I guess it seemed to other people, that getting the bet, writing a function to get the bet, seemed like a good idea, and we should put it in our main program, just like we wrote a function to get the guess and to get the flip. Why don't we write a function to get the get? And it seemed like, and I'm going to create a variable called bet, and let's call a function called getBet. So in getBet, we're going to prompt the person for their bet. They're going to type in a number, we're going to validate it, they're going to return the value, right? So let's just assume that I can write that. I know I can write that because effectively all I have to do is like sort of get guess and sort of just change that. So now that I get the bet, okay, so why don't we do this, different people? So now that I got the bet, so now what am I going to do with the bet?
I created like variables, bet 1, 0, and bet 2, 0.
So remember, we need to, because we want to print out how much money you won when you won the bet and how much money when you lost the bet. So Nimra said, let's create I'm going to create the variable names. Win total equals 0 and lose total equals 0. So I'm going to create two variables because, okay, that I'm going to want to now update each time I win and lose. So now that I've created those variables, now how am I going to enhance my code?
So when it's if guess equals to say PDO win total equals win total plus 1. Sorry, it's win total equals win total plus bet.
So over here, I'm in the code where I know that I've got the correct guess. I've won the game. So at this point, since I've won the game, what I want to do is I want to now increase my win total by the bet. Right? I know I won the game, so now this is how much money I bet. And so now I'm simply going to now increase the win total by how much I've won with the bet. And now that I've done that, it should seem clear that when I lose, I'm going to increase lose total. Ugh. So in my main routine, I'm sort of choreographing all the different calls to get the values, and the main routine is also going to keep track of some of the totals here. So at this point, okay, I'm still not reporting how much I won or lost.
So you make a change in the summary section.
Okay, does everybody see this? Okay, everybody should get it, because now my summary is not only going to report the number of wins and the number of games I've played, but it's also going to report how much I've won and lost. So I'm going to have to pass to it win total and lose total. So now I've changed my main routine to sort of collect all the right information and pass it to the right spots. And now all I need to do is to now, let me go and, it doesn't make any difference what order. So I'm going to create two additional variables here for summary because it got called with 4 variables. And so now I wanted to say you won, you lost. Okay, fine. So now this is pretty simple. So now all I'm going to do is enhance this to say you won. And now that's going to be win total. Okay, so now I'm reporting on those two values. And the only thing left to do is to build out get bet, and get bet, if I really want to be lazy, which I do, is I can sort of just copy get guess. Okay, you could have typed it all the same, but these are very similar. And so I'm going to get the, now I'll put it in a I could have used guess also, by the way. That would have worked fine, but. I don't know if I said 500 is legal. It's less than. So that's right. Okay. So this is actually right. So if I put in here in the range between 0 and 500, that actually will, if they put in a negative number or they put in 500, 500 is not a legal bet. You can't bet $500. So if it's not in that range, it's going to say invalid input, and then I'm simply going to repeat the prompt. I'm going to return bet. Hannes?
Shouldn't you give it in a range of 1 to 500? Isn't 0 and valid bet? Or no? Of 1 to 500.
You're right. 1 to 500, because if they typed, they would have entered 0. That's correct. It should be 1 to 500. Thank you. Actually, this is 1 to 499, right? Because the way the range works, it's going to be 1 less than that. So you were right. It should be 1 to 500. It shouldn't be 1 to 501, because I said here that the bet has to be less than 500, not less than or equal to 500. So those endpoints will kill you. Of course, you can always test it, and then you're going to know if it's right or wrong. And this should be actually, to be clear. Okay. So, okay, Chris, did you get it? I don't know what you did that was different. Do you see?
No, I get what you did. I just
You didn't do it.
no. For me it was just no. I'm not quite used to functions yet. It's just easier. It was easier for me to make changes to every function, like essentially most of the functions in there, than create my own. I just added the bet function in like right before the guess. It was just part of get guess.
How did you pass back both values?
I did something that you didn't teach us.
You returned 2 values?
Yeah.
Okay. So,
I did it in my homework too, because that was actually something I got.
okay. Okay, so the spoiler alert here is, because Chris couldn't control himself, so let's go embarrass him. So the spoiler alert here is that, in fact, Python, I've said here, traditionally functions return 1 value. Functions can also return a list in which has multiple values. So effectively, if you wanted to return 2 values, you could have stuffed it in a list, return the list, and take the 2. If you wanted to return 2 values, put 2 values in the list, return the list, and then just take out the 2 values. But on top of that, you can return 2 values from multiple values from a function. Python allows it. I will teach it, okay, so that Chris doesn't have the facilities that everybody else does. I'm not a big fan of it. In purist programming, it's not really the right thing to do. Functions are supposed to do one thing and return, are supposed to do a thing and return a value, and then it's supposed to return a bunch of values. But I, even that aside and the purist aside, to me it makes much more sense to break it up into 2 different functions. Do you agree, Chris?
No, yeah, it's just not used to it.
Just logically. But hopefully you're getting the feel of what you're doing with it. You have to do something called a function. And it's sort of, there is some feel for what that is. Your is was, okay, I'm prompting the user for their input, and you said get their guess and get their bet, and you said that's one. And I guess you could argue that does make sense. Okay. Any other comments or questions? So for homework, so I handed out the homework assignment. This is a fun assignment. When a teacher ever says that, what does that mean? The exact opposite. So this is, so let me bring up. You're going to, effectively, we're going to continue. I don't know why I'm doing all these games of chance, but it seemed like a thing to do. So you're now going to implement blackjack, or the card game 21. And I've explained in the first paragraph, has anybody not know how the game is played? Maybe I went through this before. Katie, you don't know? Wow, okay. So this is a very old and traditional card game, gambling game, and you play as follows. So a person plays against, in this case, the house. So suppose I'm a casino and you go to a casino, you're playing. So you get you get dealt 2 cards, and I get dealt 2 cards. I'm going to first explain it to you how it's played, and then I'm going to modify the rules for what you have to do for homework. So the way it's played in a casino is you get 2 cards. A picture card is worth 10. The other cards are worth whatever the face value is, and an ace can be worth either 1 or 11. The object of the game is to take as many cards as you like and get as close to 21, the total of 21, as you can. And the casino does the same thing. So you get two cards, I get 2 cards. You can at any point as the player say, I don't want any more cards. So suppose you get dealt a 10 and a 9, your total would be 19. You might say, I want another card so I get closer to 21, but if you go over 21, you lose them automatically. So if you said, oh, give me another card, and I give you a 5, and you had a 10 and a 9, you'd have 24, you would lose. Okay? So you had a 10 and a 9, you'd probably say, that's good enough, that's pretty close to 21. I, as the house, I would have I would be dealt cards, and the way it's played in casinos, I think it's 17. Does anybody play? They have to stop at 17?
It depends on the casino. Usually there's like a house rule. If they have 17, they can't.
Okay.
Dealer respect, you can't get another hit.
So at Pirate Casino, if I had a 10 and an 8, 18, I could not take any more cards. And then at that point, you would have bet money on that hand. If your total was higher than mine, you'd win. If it were lower than mine, you'd lose. If you went over 21, you'd lose. Okay, so that's how the game is played. It's a pretty simple game. The only thing is that the ace can count at your discretion as either a 1 or 11. In our modified game, okay, the ace would always just count as 1, so you don't have the option of counting it as 1 or 11. So you're going to write a program that's going to simulate playing this game, Blackjack or 21. So I've given a whole bunch of examples here of how this game is going to be played. So what I have, okay, wait a second, guys. So on the piece of paper, I've only printed out on the back a sample. I wanted to save paper. If you download the program, if you download the assignment from Blackboard, it has a lot more samples, which I'm going to go over right now. So your program is going to play, and so in this game, okay, you're going to print out dealing first 2 cards to player. So you're going to deal. So the first card the player got is a 10. The second card the player got is a 1. The player's card value is an 11. And then you deal 2 cards to the dealer. So the dealer got a 4 and a 7, and they're at 11. And then you're going to prompt the user to say, do you want another card? And they can type in a Y or a yes. If they type in a Y, you're going to deal them another card. Now the cards, okay, how are we going to simulate the cards? So the card's going to be dealt out. When you're dealing cards, you have 52 cards. You randomly you have a 1 in 4 chance of getting an ace. How are we going to simulate the cards? Well, how did we simulate the coin toss? They're random, right? So we're going to simulate the cards, again, by using the RAND function. Now, it's not going to be a totally accurate simulation. So you're going to simulate the cards by dealing a card generating a random number between 1 and 10. Well, no, between 1 and 13, I'm sorry. And if it's the number 11, which would simulate a jack, it's going to count as 10. If it's in 12, it would simulate a queen, it's still a 10. And if it's a 13, it would be a king, but it's still a 10 because the picture cards have a value of 10. Okay? So you're going to deal out a card, another card. In this case, they get an 8. They had 11 before, and now they have 19. You can ask if they want another card. They're going to say no. Now, the rule is that if the dealer has above 18, so if their total is 18 and above, they don't take any more cards. If it's below 18, if it's 17 or below, they have to take another card. The dealer in this thing had 11, so the dealer has to take another card. So the dealer was dealt a 7. So their total is 18. The game at that point would stop because the dealer can't take any more cards when they have 18 and above. And at that point, you're going to print out what the outcome is. And the outcome was that the player had 19 and the dealer had 18, and therefore the player won. Now, this isn't the real way blackjack's being played, but I did it for simplification. So another example is that we're going to play another game, and we deal 2 cards, and the player gets an 8 and a 4 and 8, they have 12. The dealer gets a 2 and a 4. They have 6. You ask if they want another card. You deal the card dealt once. You deal in the player another card. Strike that. They got a 1. So they had what did they have before? They had 11. They had 12 before. Now they have 13. Do they want another card? Yes. They get a 6. They're now at 19. They want another card? No. The dealer takes cards, and now they keep taking cards, and they finally were at 16. They get a 7. They're at 23, and they lose because now the dealer is over 21. We're not. The dealer busts, and the player wins. And so in the download, if you download the assignment, you're going to see this is what you're going to see. You're going to see these other examples. I explain it in the rules, but you might get an idea of better what the rules mean as you look at these different hands. So, of course, I think you're going to be better off if you break this up into functions to do this. If you think about the way we solved, or the way I solved the problem today for the coin toss, and sort of map this into what we're doing here, it's sort of similar. Instead of getting coins, we're dealing cards, okay? And we have to print out the value of the card. So this is a little more challenging. Okay, so I said something before that's wrong. Just generate, instead of generating a number between 1 and 13, just generate a number between 1 and 10. You don't have to worry about simulating jack, queen, or king. So just generate a random number between 1 and 10. That'll simulate the cards from ace through 10. You don't have to worry about there's 52 cards in the deck. That'll be on the exam. Just kidding. That would be fun. So let me strike what I said before about random between 1 and 13. It's 1 and 10. And see if you can break this thing up into functions. Unfortunately, this would have been a better assignment to give you on a Wednesday for a Monday for more time, but it's just not the way it worked out. So in deference to the fact that you have between now and Wednesday to try to do this, I'll let class out early. It's 12:11. So I would try digging into this sooner than later. It's probably going to be hard to do this if you start on this on Tuesday night at 11:30 in the evening. But as a model, look at what we did for the homework for today and see if that gives you sort of an idea of how to break things up. The good news is, if you can do this, you're probably going to do pretty well on the exam. The exam won't be this hard. It's going to take you more time than what I'm going to allow you for the exam. So it's good practice for the exam. Okay.